Hi, how are you? Hope you're feeling good. Today, I'll talk in my presentation about Unit 1, Lesson 3. I hope you feel like it. And if you have any questions, please don't be shy and I'll answer your questions privately on WhatsApp with all pleasure. This is Ms. Isra Saad from Science Team at New Generation Language School. By the end of these video students will be able to determine the concept of molecules, determine the concept of energy levels. So, our session for today is about atomic structure of matter. So, in the previous lesson, we have studied the structure of matter, where matter consists of molecules, consists of atoms. And the chemists use symbols to express elements easily, and thus this symbol of any element is represented by its atom. So we will start with the definition of atom. Atom means it's the fundamental building unit of matter, or it is the simplest individual unit of matter which can share in chemical reactions. Again, the atom, it is the smallest individual unit of matter which can share in chemical reactions, or it is the fundamental building unit of matter. What about the chemical symbols of some elements? Look at this table, then read it carefully and see it carefully to help you in the following. Okay. From the previous, we find that the symbol of the element is represented by one letter or two letters. If one letter, it is written in capital, and if two letters, the first letter is written in capital and the second letter is in a small. Number 4, some elements have samples taken from Latin languages as sodium Na, potassium K, iron Fe, copper Cu, and silver Ag. And now we are going to talk about the atomic construction. So the scientists did many experiments to reach the atomic construction, where they found that the atom consists of two parts: nucleus and electrons. Nucleus and electrons. So what is the difference between them? First, nucleus. It is the center core of the atom. It is the center core of the atom, and it's positively charged. So nucleus positive. Good reason, because it contains protons, positive charged particles, and neutrons, electrically neutral particles or uncharged. And what about the electrons? The electrons, they orbit or revolve around the nucleus at very high speed, and they are negatively charged particles, and their numbers is equal to the number of positive protons in the neutral atoms. And what about the mass of both of them? The nucleus, or the mass of nucleus, the mass of the atom is considered concentrated in the nucleus, because the electrons have a negligible mass relative to that of the proton or neutron, and the mass of electrons, the electron has a negligible mass relative to that of the proton of neutrons. And now give reason. The mass of atom is concentrated in the nucleus, because the electron has a negligible mass relative to that of the person neutron. So again, because the electron has a negligible mass relative to that of the proton or neutron. Give reason. The atom is electrically neutral in its ordinary state because the number of negative electrons which revolve around the nucleus is equal to the number of positive protons in the nucleus. Super. To express an atom of many elements, we use two terms which are mass number and atomic number. What are the difference between them? First, we will start with atomic number. It is the number of protons in the nucleus of an atom, and it's written below the symbol of the left side. As you see, the atomic number here is 13, and the mass number, it is the sum of numbers of protons and neutrons in the nucleus of an atom, and it's written above the symbol of on the left side. Okay, thank you. What is the meant by? The atomic number of calcium atom equals 20. This means that the number of protons in the nucleus of calcium atom equals 20. Number 2, the mass number of calcium atom equals 40. This means that the sum of the numbers of protons and neutrons in the nucleus of calcium atom equals 40. And now it's time for give reason. Give reason for the following. Number 1, the mass number is always larger than the atomic number, because the mass number equals the sum of the numbers of protons and neutrons in the nucleus, but the atomic number equals the number of protons only. And from the previous explanation, we conclude that atomic number equal number of protons equal number of electrons, and the mass number equal number of protons or atomic number plus number of neutrons, and the number of neutrons equal mass number minus atomic number. What happens when the number of protons changes? First, the value of positive charge of nucleus changes, and the value of atomic number and mass number change. So, the element changes into another element. Perfect. Example, number of protons equal atomic number, number of electrons equal atomic number of neutrons equal mass number minus atomic number, as I said. For example, the number of protons equal 8 and the number of electrons equal 8. So the atomic number equal 8 and the mass number equals 16, and the number of neutrons 16 minus 8 equal 8. So we talked about the oxygen gas. Problems. If the nucleus of an oxygen atom contains 8 protons and 8 neutrons, find the atomic number and the mass number of the oxygen, and how the symbol of oxygen element is written. About the solution, the atomic number equal number of protons equal 8, and the mass number equal number of protons plus number of neutrons, as I said, so equal 8 plus 8 equals 16. And the symbol of oxygen element is O816. Super. Number 2, if the nucleus of sodium atom contains 11 protons and its mass number is 23, find the atomic number and the number of neutrons. About the solution, the atomic number equal the number of protons equal 11, and the number of neutrons equal mass number minus atomic number equal 23 minus 11 equal 12. Brilliant. And now it's your turn. What is the meaning of atomic number? And you have 10 seconds. Brilliant. You're amazing. And now we are gonna talk about the energy level. Energy levels. What is the meaning of energy levels? They are imaginary regions or places around the nucleus in which the electrons move according to their energies. Again, they are imaginary regions or places around the nucleus in which the electrons move according to their energies. So the maximum number of energy level is the heaviest or largest atom is 7. The energy level are arranged according to the nearest to the nucleus from the inside to outside as following: K, L, M, N, O, P, Q. Super. Don't forget that each level has a certain amount of energy that increases by increasing the distance from the nucleus. And now we're going to talk about the quantum. Quantum. Quantum means it is the amount of energy lost or gained by an electron when it's transferred from one energy level to another. And what about the excited atom? It is the atom that gains a quantum of energy, so the electron is not transferred from the level to a higher one unless it gains some energy called the quantum, which equals the difference between the energies of two levels, and the atom in this case is known as excited atom. Super. What happens when the electron gains a quantum of energy? It will transfer to a higher energy level, as we said, and atom becomes excited atom. Brilliant. Number 2, the electron is in the excited atom lose a quantum of energy. It turns to its original energy level and the atom turns to its original state or to the ground. Perfect. Don't forget that each level has a certain number of electrons. For example, the first energy level K has the least energy, and it starts by 2 electrons in level 2, 8, level M, 18, level N, 32. Super. Give reason for the following. The relation 2n squared is not applied to the energy levels higher than 4 because the atom becomes unstable if the level contains more than 32 electrons. So each energy level can take a definite number of electrons, and the electrons are distributed in the first level K, then the second, and so on. The number of electrons which are situated the first 4 energy levels can be calculated from the relation 2n squared, as we said. Perfect. And now we are going to talk about the electronic configuration and the chemical activities. The chemical activities of the atom of an element is determined related to the number of electrons in the outermost energy level as follows. So we have 2 examples, active elements and inactive elements. How can we differentiate between them? First, we'll start with active element. The outermost energy level contains less than 8 electrons, but in active elements, the outermost energy level is completely filled with 2 electrons except helium. Helium has 2 electrons. And the atom of active elements unstable, but inactive elements stable. Good reason. In an active elements take part in the chemical reaction, but in inactive elements don't take part in a chemical reaction in ordinary conditional. give reason to to produce the stable molecules because and in inactive metal elements because the amount or the outermost energy level are completely filled with electrons. For example, active elements such as sodium Na and inactive metals such as argon Ar. Brilliant. Don't forget that the electrons of the outermost energy level are responsible for the chemical reactions in the helium He2 for it is the only inert gas that has two electrons in the outermost energy level K. Perfect. And now the electronic configuration. Focus with me in our session to know how can you do it. Thank you so much. See you later. Goodbye.